So rational expressions, so just to review, ratio means fraction. Okay? Now the term non-permissible values, restrictions on a variable, we also are going to call them NPVs. They're really important in this unit when we're dealing with fractions because we cannot divide by 0. Okay, so they result when your denominator, what would make your denominator 0? Because we cannot divide by 0. So there are non-permissible values. Values for our variable that are not allowed, not permissible. NPVs, because they are the values that would make the denominator 0, just not possible. So let's plug and play a little bit. If x was 0, what would this fraction equal to? 12 over negative 1, which equals negative 12. Good. 12 over 7 minus 1 gives you what? 2. 12 divided by 6 is 2. 12 over negative 2 minus 1. What would that give you? Negative 4. You have to subtract first before you can divide. 12 divided by 1/2 minus 1. What's a half take away 1? Negative a half. And 12 divided by negative half. What would that equal? No. Negative 24. Negative 24. Okay, and if x was 1, 12 divided by 1 minus 1. Oh no! We get 0. Is that possible? No, that's undefined. So why is 12 over 0 undefined? Well, let's look at it, think of it this way. Okay, if 12 over 0, let's set that equal to x. Okay, if we set 12 over 0 equal to x, I'm going to cross multiply to get 12 equals x times 0. I'm basically multiplying 0 by both sides. Okay, is there a value of x, any number, that when we multiply it by 0 will equal 12? No, anything times 0 is always 0, so that's just not possible. It's not possible. And so that's one way you can explain why you can't divide by 0. Okay, so a rational expression is undefined when the denominator is equal to 0. So values of the variable that make the denominator equal to 0 are called our NPVs. I'm very lazy. I do not want to say the word non-permissible values every time, so we'll call them NPVs. Is that okay? Sounds good? You can identify with that? So what we're going to do is, before we do anything, we want to make sure that we know how to find NPVs. Okay? So the NPVs are the values that would make the denominator 0. So here, x can't be what number? 0. X can't be 0. Number 2, what would make the denominator 0 here? If x was 3, x can't be 3. This actually brings us back to quadratics a little bit when we were finding the zeros. Same kind of idea. X can't be equal to what? 2.5. Or as a fraction? 4 over 2. Okay, do you remember from quadratics the shortcut? Opposite side, b over a. No? Okay. The reason why it's that is we set 2x minus 5. If we set it equal to 0, we're adding 5. Right? Solve what would make it 0. And then divide by 2. And so x equals 5 over 2. So when x is 5 over 2, the denominator is 0. So the shortcut, just like when you're finding zeros in quadratics, opposite sign, second over first. There's a number in front of that variable. Okay, 4. Okay, good. It can't be 5 over 2 or 3. And the reason why, if one of these is 0, does the whole denominator become 0? Yes, because 0 times anything is 0. Right, just like with quadratics. So we're actually pulling in some skills that we have. Some skills. Math skills. All right. Try the next one. What can't x be? Close. And 4. Okay. So, yeah. Are we needing another explanation? Are you understanding this? No. Okay, so we're figuring out what, for each one of these factors, we're figuring out what would make it equal to 0. Right? What value of x would make it equal to 0? Okay. So subtract 1, divide by 5. That's how we get negative 1/5. Add 4. That's how we get 4. Good? Okay. 6. Ooh, that's interesting. 2? Is that the only answer? Or negative 2, plus or minus 2. So often what we do before we state NPVs is we actually want it in factored form. And this right here has a very special name. Difference of squares. Okay, so guess what's going to be more important than ever in this unit? Factoring. Factoring, factoring, factoring. That's all we do over and over all the time. There are some fun moments I'm going to show you today that feel really good. But the factoring part, as long as you're good with the factoring. Okay, so how do we actually factor this? Plus 2 and minus 2. And so now it's easier to see your NPVs, and you're less likely to miss one. So a lot of you might have spotted positive 2, but might have forgot about negative 2. In factored form, we can now see both values that would make the denominator 0. X can't be plus or minus 2. Cool? Okay, so guess what you need to do with number 7? Factor. Okay, so Chinese method 3, 1. 5, 1. Try that. Does that work? 3 and 5. We can make that a negative 8 if we do what? Make both negative. Okay, both negatives would multiply to positive 5. That works. And then our diagonals would add to negative 8. So we would now rewrite this rational expression as, so remember the first row is the first term, second row is the second term. So the first is what? Good. X minus 1. Okay, so our NPV would be x can't be 1 or 5/3. Okay, NPVs for the last one. I really like this last one. It's already factored for you. Notice it doesn't matter what the numerator is. All that matters when we're finding NPVs is just the values that make the denominator 0. Can you go 0 divided by a number? 0 divided by 12? Yeah, that's equal to 0. That's fine. We just can't divide by 0. Okay? You can't take 12 things and put them in 0 groups. Okay. They go 0 go in each 12. 0 go in each 12 groups. Yeah. Okay, what's the NPVs here? So we look at each factor. It's already factored for us. So so negative 5, positive 2. The last one is 3/2. Is there any other ones? Careful. 0. Okay, so what would make this 4x equal to 0? 4 times 0. If we divide both sides by 4, we get x is equal to 0. Okay, so a monomial, just like a monomial, kind of related to radical, it's not really, but a monomial would just be 0. Because 0 times anything is 0. So there's 4 NPVs here. There's four factors with x. All right, let's have some fun with simplified. Okay? I love simplifying. You'll see why. Okay, so reducing fractions, you could think of the reason why fractions can reduce is 15, you can think of it as 3 times 5, and 20 you can think of it as 4 times 5, and therefore what would cancel? The 5s, which is equal to 3/4. Okay? So we're going to be doing something very similar. We're going to be breaking up our polynomials into their factors and then reducing common factors. Now, what's really important here is that you would only reduce a monomial with a monomial and a binomial with a binomial. No ripping limbs off of expressions, okay? Maybe it sounds morbid, but don't write this down, but just listen, okay? I will see students do this all the time. Right? Right? Does that happen all the time?
Yeah.
Yeah, but you can't do that. We can't divide before we subtract. Right? There's invisible brackets here. And so we can't reduce a monomial with a binomial. That's like the biggest no-no in the book. Okay, and I'm going to try and break you all of that awful habit. Awful. Okay? So what we need to do is always factor. You can reduce a monomial with a monomial, binomial with a binomial, okay? So let's look at this guy. Can we factor? So first step, factor. What can we factor? I'll give you a hint. Starts with a G, then a C, and then an F. GCF. So 4 and x out of the denominator. Okay, we can GCF the denominator, and we're left with x minus 3. Okay, now can we do some simplifying? Yes, because we have a monomial factor and a monomial factor. Now you can reduce these. Okay, so the 8 and the 4 reduces to 2 and 1. We divide both by 4. X cubed over x. Just an x squared. We divide both by x. I'll just erase the 1. Okay, so now we have left on the numerator 2x squared all over x minus 3. We always have to state NPVs. And here's the part that you might want to highlight. You must set NPVs after you factor, but before reduction. So when I state my NPVs, it's at this point here, before reduction. Because it also must be true for our original expression. Okay? So our NPVs before reduction. So we look here. Okay? What would be my NPV? So I write comma x can't be equal to 3 or 0. Good. That is my answer. Okay? Now, I'm really excited for the next one. This is where it gets a lot of fun. I don't know about you, but that feeling of canceling things out feels so good.
I like home.
You like calm better? Oh. Home? Okay. Okay, the first one, 1 and 1. I'll do the Chinese method on top. What two numbers? Multiply to negative 10, add to 3. Shh. What two numbers? 5 and 2. Who has to be negative? 2. Good. Okay, so the first one factors to x plus 5, x minus 2. Okay, denominator, 1 and 1. What two numbers? 5 and 3. So we have x plus 5 and plus 3. This is the fun part. This is the part that feels so good. What cancels? The binomial with the binomial. They have to be identical, but it's the fact we can only cancel factors, not terms. It's another way to think of it. Factors can cancel, not terms. You can't go and cancel these terms, x and x, right? The binomial factors can cancel each other out. Binomial, binomial, monomial, monomial. So now we state our answer. Our answer would be x minus 2 divided by x plus 3. And then my NPVs, x can't be equal to negative 3 and negative 5. Remember, we look before cancellation for NPVs. Right? Before cancellation, that's where we do our NPVs, because they have to be the same NPVs that were for this guy. So if I plugged into negative 5, even though 5's x plus 5's cancel, if I plug in negative 5 here, I get 25 minus 40 plus 15, which gives me 0. Oh, we only do for denominator, right? You can have a numerator of 0, you just can't have a denominator of 0. Okay, factoring skills. Should we do it together? You guys can do this. 2, 1. Let's try what? 5, 3, I guess? Okay, will that work?
As far as we know, yeah.
6 and 5, who has to be negative? The 6 to make negative 1, so that means the 3 is negative. Okay, on the denominator, 3 and 1, I have to make 13. If I do 2 and 2, are my numbers going to be large enough to make negative 13? No, so we want to try 4 and 1, or 1 and 4. 1 and 4. Okay, 1 and 12. They both have to be negative. Then we have negative 12 and negative 1. Good. So it's kind of assumed that you can factor, hey? When you were in grade 10, you're learning about factor, you're like, when am I ever going to do this again? Like all the time in math, grade 11 and 12. Maybe not so much after. Okay, next one. 2y plus 5, y minus 3, y minus 3, 4y minus 1. And what happens? Y minus 3. Doesn't that feel so nice? Love that feeling. Clearly, I need to get out more. Oh, clearly. 2y plus 5 divided by 4y minus 1. Can we go and do something like this and reduce here? No. We can't simplify terms, only factors. You can't rip things off that are attached. It has to be a monomial with a monomial, binomial with a binomial. These are binomials. Okay? Okay, what's my NPVs? Y can't be, not x. 3 or 1/4. I know, I did too. Okay, where do we start with number 4? Factoring 5 out of the numerator and GCF. Yeah, GCF. What are we left with? Y squared minus 9. Right away, an alarm bell should be going off in your head. If you know how to factor and you're like in the habit of factoring. Because when you see y squared minus 9, you should be thinking what? Good. Y plus 3, what? Difference of squares. Okay. Denominator, we can GCF 10, and we're left with? Oops. Okay. Who says me? Sorry. Just factoring 10 out. Not that hard. Okay, so numerator becomes 5 times what? You said it already. Y plus 3 and y minus 3. Denominator, can we factor this beautiful trinomial? Yes. Y, see, 1 and 1. What are the numbers going to be? 4 and 3. And who is going to be negative? 3. Right? Negative 3 plus 4, that'll give you 1. And now the fun part. Part you've earned. So you do all that factoring to earn the right to cancel. What cancels? Okay, the y minus 3's. Anything else? 5 and 10 we can reduce to 1 and 2. Okay, so we leave things in factored form, especially if there's more than one factor. On the numerator, is there just one factor or more than one? Just the one, y plus 3. So that doesn't need to be in brackets. How about the bottom? Yes, we need brackets. 2, we leave it in factored form. 2 times y plus 4. Are we done? Good. Restrictions. How are you restricted? Can equal close. Negative 4 and 3. Right? Before cancellation. 3, negative 4. And make those zeros. Turn the page. Right? Okay? So I'm looking here for my NPVs. Factor form, but before, like after factored, but before cancel. Okay? Really? That sucks. This unit's gonna be a long one for you. Alright. Oh yeah. You get faster and faster, I promise. You really do. Get okay, so GCF. Alright, so GCF, what can you factor out of the numerator? Guys? 8x. Beautiful. 8x what? Squared. Good. So when I divide, I factor out an 8x squared. A common mistake I'll see is students will just write this. No. Okay? Because when you factor something out, we're dividing each one of them by that factor to see what's left over. When you divide 8x squared by 8x squared, what does that equal? 1. Oops, that's not a pen. 1 and then minus 8x cubed divided by 8x squared is just x. Okay, on the bottom, what can we factor out? 4x, and we're left with x minus 1. Very good. Now, I have a question for you. A big question. Is 1 minus x the same as minus 1? The answer is almost. Right now, no. Okay, they're not the same. But is there a way to kind of make them the same? The problem here is that they're opposite signs, right? Right now, they're opposite signs. Maybe. Okay, I'm trying to explain it. So right now they have opposite signs. So this is 1 minus x. This is x minus 1. Here the x is negative. Here the x is positive. Here the 1 is positive. Here the 1 is negative. Right? Right now they're the opposite signs. So how do I make the signs the same? How could we make the signs the same? Any ideas?
Times by -1.
You're like right there. Instead of saying timesing, we could say factor out -1 from one of them. Okay, so what I mean by that is if I took, for example, 1 minus x, and we factor -1 out. Okay, so I'm going to factor a -1 out. That means we're going to divide each of them by -1. 1 divided by -1 becomes -1. And -x divided by -1 plus x. Is -1 plus x the same as x minus 1? Yes. Okay, so what we're going to do, yeah, they're not the same right now, but you can, if they're just opposite signs, we can factor a negative out. So I'm going to put that in front with the 8x squared, and we can switch the signs. So -1 plus x, we switch the signs. We only have to do that to one of them, okay? Would you agree that those are the same?
Yes.
Yes, these are the same. And since they're the same, what happens? You get to cancel. You get to. Keep that perspective. It's privilege. It's fun. What else cancels? Okay, 8 and 4 we can reduce to? Yeah, -2 and 1. X squared divided by x? Just an x. Okay, so what's our answer? Just -2x. What's my NPVs? X cannot equal 0 or +1. Okay, so if they are almost the same, but their signs are opposite, factor out the negative and then you can cancel. Okay, fun times. So remember, only can reduce monomial with a monomial, binomial with a binomial. Good? Okay, so with that, let's talk about your homework and what I expect from you guys. Your assignment is page 317, 321, numbers 1 to 9 and 11. Now listen, guys,